I didn't create it, but it's made by a guy named TriEmbed Hudson, and that's 2 M's and 2 L's. He's, I think, out of New York City. He does projects with this group, NYC Resistor. So over the years, they've done a number of things, like they've had the WS, is it 8.2 or 2.8, you know, smart pixel displays, and they've made video walls out of those, and just a number. And I think what they do is they basically have like a makerspace, and then they get people together and they say, okay, well, this is what we're going to do. So bring your stuff, or bring some money, and then we're all going to sit down and do this so that they all get experience and get to learn it. So one of the projects he had was to use oscilloscope to display the old late 70s, early 80s vector arcade games. So it looks like everybody who's old enough to remember those. You know, it's like the original computer graphics back when kilobytes of RAM were very expensive, so you certainly couldn't have bitmap displays, and certainly not for arcades. The only way you could affordably do it was have a small, you know, 1 kilobyte of RAM that's a table of vectors, and then some digital analog converters, along with maybe some simple RC integrator that would draw nice straight lines on a tube. In the arcade, they typically used a magnetic deflection screen. So I think basically it was like black and white TV with some modifications to the high voltage circuitry and deflection. So it was faster, and then you know, it would display lines on the screen. And I think later games had color and control over the intensity. But so what he's done is he's got a TNC 3.1. And the reason for using the 3.1 is that it supports DMA. And DMA is important because the job of the TNC is going to be 2 things. It's going to be listening for basically commands that tell it what to draw, and then it's going to store that in RAM, and then it also has to constantly update the display, because if it's not doing it constantly, then you stop seeing it. It's basically a persistent vision trick. So it has to run really fast using DMA, searching a segment of memory to keep drawing the vectors, or actually basically just sending data to external DA converters over and over again, while also listening to the USB serial. So I don't know if you really do that on an 8-bit at Mega. Probably not, or probably not in a way that would be satisfactory. So yeah, basically I brought this setup. I didn't bring a laptop because I forgot it going out the door, but it's okay, because if nothing's hooked up, it will show a test pattern, and it actually looks pretty good. And as far as, you know, the games go, it's pretty cool to see them live again. You can emulate these. Yeah. You know, it's funny because it seems like I've had trouble with the games that are color, and I think it's because he's basically done a hack to what's called MAME. What is it called? Multi-architecture machine emulator, or multi-arcade machine emulator. I think that's how it is. He hacked the vector output through serial into it, and some of the games seem to have a problem with it. I'm not really sure why. But
is this like games like arcade, like
Asteroids, yeah, that kind of stuff. So that's cool. Unfortunately, they don't make vector magnetic deflection displays anymore. But oscilloscopes aren't hard to find. And in fact, this is one instance where you really do want an analog scope, because if you run it through a digital scope, unless you've bought like a really expensive LaCroix or something like that, most of them are 8 bits. And 8 bits is going to make your vector graphics look kind of bad. So it's really, you know, the old analog scopes are really the best for this sort of thing. So the other thing he's done, and I haven't really played with it too much, is that in essence, he has like a library for graphics and text. So, you know, they've already got really nice fonts set up with, take advantage of the fact that the DACs, which are microchip 4922s, which are dual 12-bit DACs. So 12 bits gives you 4,096 points, and that is a lot on a 5-inch display. So the arcade games typically have 10 bits on a 19 or 21-inch screen, and I don't ever remember seeing stuff jump around. There's a home system that came out around 82, 83 called the Vectrex, and that used 8-bit converters, and on that you can sometimes see things jumping and getting a little wonky looking because you've only got 8 bits, and when you're rotating stuff, you just don't have the precision. But in this case, you got 4,096 by 4,096 pixels. So you're never going to see that on a tiny screen. Interesting thing about that resolution, I don't know if anybody remembers, I certainly remember seeing it very young. It was probably the first computer graphics I saw, which was a Tektronix 4000 series terminal. And it basically is the same thing as this. Its job was it listened to probably like a PDP 10 or 11 or something like that. It probably took serial at about 9600 baud. And then its job was to just sit there and write stuff to a pretty big, I think, was it electromagnetic deflection, or it might have been electrostatic. In any event, about a 10-inch display. It wasn't very bright. It could show text, but its main feature was it has analog storage. So it would sit there getting commands from the PDP that basically told it, move the beam and write stuff, and you could see it writing. And then when it was done writing, it would turn on like this, in essence, like an electron flood lamp that would keep the phosphor lit where it was struck by the writing beam. So I guess it was useful for seeing a CAD drawing of something like that, rather than having to print it out. And it too had 12-bit DACs, so you had 4096 pixels, which was, at the time, bitmap displays were, 192 by, 120 or something like that. So
yeah, I did my first computer graphics on one of those, and was using 8-inch floppy disks.
Yep.
Everybody remembers 8-inch floppy disks.
So he's released, like I said, he's, unfortunately, I can post it to the list, I will do that. It's a little bit, there's not a lot of hand-holding on his projects, it's more like, I guess, for him and his buddies at NYC Resistor, but he does use GitHub and he does post code there, and there are basic instructions for building this. I think really the hard part is compiling his version of MAME. But if you don't really care about the games, then it's as easy as getting, cloning his GitHub repository, loading the code onto the TNC, and then just, there's some easy examples where you can see that, sending text or setting graphics primitives to the thing. And, because he's using DMA, once you send something to it, it just sits there and keeps it until you tell it to, clear the display or write lines somewhere else. So I think he's hoping to use processing and allow people to be creative with that, where you can write code in processing, which I guess is like the GUI interface for allowing students or anybody to get data from the Arduino back to the computer and be able to display it in a graphical sense, to graph things and make charts or whatever. So it would allow people to just draw arbitrary stuff through processing and then have an easy interface for that. So if anybody has any questions, hit me with them. I'm going to just get this turned on and we'll see. It just shows a static demo screen because, like I said, I forgot the laptop.
What kind of clock rates are jumping around on your breadboard?
Yeah, pretty high frequency. Haven't really measured it. I'm guessing you can run SPI at about 20 megahertz with the TC31. It's got like the ability to have normal speed, like 48 megahertz or 72, or you can overclock it to 96. I honestly don't remember what I might have just programmed it as a default. But you'll see in the demo, it's writing, it's sending a decent amount of vectors to it, and it's not flickering that bad. And I think he can definitely improve it. I noticed that if you subscribe to his GitHub repo, you can see it's pretty active in terms of changes. And one of them I know they're working on is a better sorting algorithm for vectors. So it's smarter about, if it's got a line up here in the top left corner and there's another one, it's going to prioritize them, sort of try to not jump around much. Also, knowing how to do that well is good for things that don't have a blanking input. This scope has a blanking input, but one of the things he likes to suggest that if you were looking for a vector display, you don't want to buy a scope, there's things called broadcast vector monitors that were used to show the phase relationship for NTSC video standard. And those are super sharp, and they're not that old, and they're pretty abundant. But they don't have a blanking input, they only have XY. So his trick there is to throw the beam off to some coordinate where you'll hopefully have it off screen, and then probably just draw things either faster or slower, or draw them more than once to get more intensity. But he does have the ability to use the blanking, and I don't think I have this programmed for that, because I have this programmed for the vector scope, which has the advantage of being faster. It's got a Vectrex mode, and the Vectrex had a magnetic deflection CRT, which I don't think was too far off from a black and white TV, so it's very slow. And so to get good graphics on a Vectrex, he slows the DVDT way down so that corners don't get rounded off and other bad stuff happen. So, like I said, I wanted the faster refresh, and so I just chose his vector scope code, which doesn't have blanking. So,
Oh, then NVIDIA could use this, couldn't they, as new technology for?
oh yeah, but this is for old folks. I mean, because they're never going to make these things again. No one's, unless people go crazy. I don't ever see a factory reopening and going, let's make CRTs for people who are nostalgic. This is kind of like if you want it, do it. You know, grab your display and do it. The final thing I'll say that is, for the truly dedicated, it is possible to take a CRT and modify it for XY mode. And it basically comes down to a couple of things. The first thing is that CRTs were made to be cheap and run at one frequency. So for American television, I think it's 15 kilohertz scan rate, horizontal scan rate. And they took advantage of the fact that we're going to run at that. So there's something called a flyback that generates the high voltage by means of pulses. And they figured, well, why don't we run the flyback at 15 kilohertz so that we can tap that and create the ramp for the horizontal deflection will also run at 15 kilohertz. Now, the downside of that is that, there's that deflection coil for horizontal is designed to work in unison with the flyback. So if you change that coil, it messes up the flyback. So you kind of have to keep that.
Computer monitors should be better than TVs?
Actually, no, because computer monitors typically have other sophisticated stuff on the tube for controlling geometry. So there's a lot of other coils. So ultimately what you want to do to turn your TV into an XY monitor is you want to take the yoke off, and the yoke is where the coils are that cause the deflection of the electron beam. And you want to take that off and rewind it. Typically you want to wind that to a much lower impedance than the TV, because the greater your inductance, the slower it's going to react to high frequencies, and so you want typically something that's just a couple of ohms.
Yeah.
And that's actually why a lot of the arcade display, the old vector arcades are broken, because they made these things and want them to be cheap. They figured, well, a game's only going to last a year before people lose interest, so let's not go nuts with the monitor. And what they would do is they cheap out on the deflection circuitry, and they would overdrive it. So they would, they'd get something that could produce the change in voltage and throw enough current into the coils, but maybe didn't have enough heat sinks. So typically what happened is after a few years your deflection circuits burn out, and then if the protection circuitry has also gone bad, then it sits there and burns this nice hole in the phosphor on the screen, so it ruins the CRT. So that happened to a lot of the arcade screens, and that's why there aren't many around, and they're very expensive when you get them on eBay. So I'll fire it up. Just come on over. Hopefully it won't embarrass me.
You can get a remote control set of 5. Is it?
Aren't a lot of them being coded up and put on emulators?
Yeah, exactly. You can definitely run the arcade games in the emulator, but what you lose is there's just something about drawing lines on a CRT that you just can't quite get. Like, for example, asteroids. When you shot your little missiles, they would set the intensity really high, and what would happen is that the phosphor would hit the screen and kind of splatter, and there'd be a halo around each little dot as it went on the screen. So I've yet to see anybody emulate that low. But just if you just want to play with them, you don't care, then sure, it's fine to just run them on
The hyper sharp vector graphics.
We got the little ones that stay on for me now.
Of course, I haven't seen it in decades.
All right. Maybe this will work.
The right time, usually it's set for Christmas vacation in the middle afternoon. Saturday. Remember to do that.
the scope sometimes acts up because the contacts for all the switches are probably getting oxidized. There we go. So you'll have to come up to look at it, it's not that big, and it's just a simple static display to help align things. I'll just talk a little bit more about the circuitry on the board. Here's the TNC 3.1. The next two chips are the DACs. And then the final thing is that in theory, you could just take the output from the DACs and put it to your scope. And you might be able to use your precision offset controls and your amplifier to get it on the screen, but ideally what you want is you want 0 volts in the center because it just makes it much easier. And then there's other devices like the Vectrex that really expect customized voltage. So the last bits here are just a quad amp and then a double channel using one side. So basically what that's doing is taking the output from the DACs and then shifting it so that rather than going from 0 to 2.5 volts, it's going to swing plus or minus 2.5 volts. It just makes it easier on the scope.
Somebody wrote to the mailing
So it's pretty
list
sharp.
on 24 room.
You can see that he's cheating here with high bill.
Just so you don't walk too close when I hold it. Was using a motor drive where I was doing a survey, where I was reading potentiometers. And I was taking the potentiometer and I was using that.